Hello everyone, in today's video I will try to live code a Cirrus module for a typical Node.js application. If you're watching this video, I assume that you're already somewhat familiar with the Cirrus configuration format, either by using cirrus-ci or cirrus-ci. If you are not familiar with the Cirrus configuration format and how to configure Cirrus tasks in YAML, please go to cirrus-ci.org and go to documentation, writing tasks. This page fully describes all the options you have for configuring Cirrus tasks using the YAML format. And in today's video, we are focusing on the next step in the how you can configure Cirrus tasks, which is by using Starlark and generating them with the unlimited possibilities. You can also check documentation about Starlark on the next page, the programming tasks in Starlark. But in this video, we will basically cover all the things that you will find here. So let's jump back to the slides and go to the second slide, which explains what is Starlark and why we chose Starlark for the generating Cirrus tasks. But first, let's think about what is a typical YAML look like for CI, not for cirrus-ci, but for any CI that uses YAML configuration format, which is a lot, and it's understandable. YAML is a great language. It's very human readable. It's easy for us humans to read it, but there is one core problem. YAML language is declarative by nature. It's meant to be for declaration purposes. You declare things using YAML. But if you think about it and about any CI configuration format, you end up with YAML with embedded bash scripts. And then if you want some non-vanilla cases, then you are thinking about how to introduce if statements to like execute some tasks only if, for example, if no source code is changed, you don't want to like run tests if it's like only documentation, or you're thinking about how to do for loops in order to like generate the same task for different versions of, for example, Node.js, and then you end up with every vendor of CI or like YAML configuration format, you end up with its own DSL for doing all these things, how to do if statements, how to do loops, and then how to do imports of another YAML files. And it's not standard. It's very different for each and one of the CI configuration formats. And with Starlark, there are a lot of things are fixed by design. So what is Starlark? Starlark is basically a subset of Python without classes. You have only method structures and all the familiar most of the familiar standard library of Python. It's very easy to write some like short programs, and you will hopefully see it in a few minutes in this video. It's like really easy, and if you are not familiar with Python, it's still pretty doable, especially for like small things like CI configuration. You are not planning to write like next Facebook or Google using Starlark. And yes, Starlark is basically a subset of Python. It was developed at Google back in the days for their like build system called Blaze internally, and now it's open sourced as Bazel. And Starlark was designed to be embedded in a larger system, and it has a really great integration. You can run it in memory instantaneously. You don't need to compile it. For example, some of the tools nowadays are trying to use WebAssembly, which is nice, but for like some if statements for loops, I think it's an overkill, and Starlark is basically very convenient for those purposes. So let's continue now with the coding, because I've already had enough words, and let's go to Cirrus template for a Cirrus module. So we created a separate GitHub organization called Cirrus modules, and you can find an example template that you can base your future Cirrus modules from. So it's as easy as just clicking use template, and it will create a new repository based on this template. I've already created Cirrus module for the Node.js, and I have it open in IntelliJ. So let's switch to IntelliJ, and I will walk you through the project structure and how it looks before we start coding the implementation of the Node.js related things. So here's my IntelliJ. So this is IntelliJ Community Edition. We created a special plugin for Cirrus Starlark dialect, but it can work for any Starlark dialects, but there are some additional code assistance for Cirrus specific things. And we were able to reuse a lot of things that IntelliJ already provides for Python, because Starlark is, as I mentioned, a subset of Python, and you will have all the fancy refactorings that you are used to. It's like all the extractions and code assistance. Cirrus Community Edition is completely free, so even if you're using a different IDE or a text editor while you're working on CI configurations, you can still download this IntelliJ Community Edition absolutely for free, just for the purposes of programming cirrus-ci tasks. So let me enter presentation mode. So it's easier for you to see all the things. And let's start with the project structure. Each cirrus-ci module has cirrus.star file, which is imported by default. As you can see in this node repository that I just created from the example template, we have only one method that generates a single hello world task that uses a Debian container and simply prints hello world in its greeting script. As you can see, we are already loading some external modules. There are some helpers that can help you generate tasks with the different instances and different instructions, which are very handy instead of just like creating objects and returning them. So you can also see that there is a tests folder in this repository. Yes, you can test your CI config. Finally, it's really hard with YAML to do any assertions, to check some things, to check this if statements and so on. Let's first take a look at the test. So single test looks like a Starlark file that can import the locally available lib.star, and then it simply has a main method that should return a list of tasks. And what these tests are doing, the test framework that we have, this test framework basically compares the output of such invocations of main with the expected YAML format, YAML configuration that you expect. So yes, Starlark actually generates just YAML, which is then parsed all together with your existing cirrus.yaml file, so you can seamlessly integrate and reuse things between them. So in this example, you can see that the expected hello world task looks like this. Yes, it's a little bit more explicit than you are used to writing tasks, but this is generated, which should be fine. And how to run it? How to run tests? For running tests, you need to have Cirrus CLI locally installed. You can find instructions on that in Cirrus labs/cirrus-CLI repository. As you can see, we also have integrations with all the popular CIs, because cirrus-CLI is a tool that can execute Cirrus tasks locally on your machine, on your laptop, or in any other CI, not only cirrus-CI. So it's very convenient to just experiment and have very fast feedback loop when you're trying new things with your configuration format. And it's basically just things that can be executed locally the same way they're executed in CI to like reproduce some weird cases and so on. So yes, let's jump back to the IDE, and since I have already Cirrus CLI installed, I can simply go to my terminal and run Cirrus internal test, which will run tests for this module. And as you can see, everything is passing. So for example, if I will modify the expected YAML file just to check that our testing framework is working, I run it again, and some tests are failing, and it's like nicely prints that it expected 96 here that I just deleted. Let's revert it back, and now let's jump into generating tasks for Node.js repository. First, let's think what we want to generate. And for this purpose, we can again go to documentation. We have a separate page with a lot of examples. These are YAML examples at the moment, but we will soon migrate most of them, if not all of them, to Starlark. So now we can go to Node and see a task configuration for a typical Node.js repository. As you can see, it has some caching instruction, there is tests, and using container node latest. Let's now switch back to the IntelliJ and to our repository, and let's try to generate the same task using Starlark. So here I am in the lib.star. Let's start by renaming our hello world method into node. Let's call it node script task, and this method will simply generate the task that you saw in the examples on the examples page. So now it renamed. As you can see, it changed the test, but as you can see, our Starlark integration with IntelliJ is not yet superb. It didn't rename this reference, so let me fix that first. Okay, let's go back to the task generation. So in our use case, we had the name test. For the task, we used the node latest container, and we also had some cache instruction. So unfortunately, cache right now is not imported from the helpers, so we can go back up and simply import cache. Now it resolves perfectly and can highlight what kind of arguments this method is accepting. So in our case, we name it node modules. Then the folder is node modules. Sorry for my fat fingers. I have a weird setup with the microphone, and I'm not used to typing in this position. So and okay, so the fingerprint script is cat package. What we have there, package lock.json, right? Yes, .json, and then finally we have populate script. In the case of npm, it's npm ci. We will support yarn as well, but just in a little in a few minutes. let's finish with this first. And then we have the test script that simply runs, what was that, npm run test, right? So now we can try to run tests, but this is a bit useless because it will definitely fail, because cirrus.expected is still expecting the hello world task, as you can see. So what we can do here is actually run a Cirrus internal test -- update, which will update all the fixtures, including this .cirrus.expected.yaml. So now, once IntelliJ will pick up the file system changes, you can see that now it generates a task that runs npm run tests. Yes, it does look different than what we have in the examples, but in the examples, this was written by a human, and it used a little bit more concise syntax. That's fine. As you can see, it defines the default CPU and memory. It uses a bit more explicit syntax for the name, but it's essentially the same task. It's a bit more explicit, but yes, it's the same task. Wonderful. So we generated. Let me also rename the test into npm. And now we can commit it, right? So let's select everything and call it node script task. Node script task. Wonderful. So we committed our initial implementation. Now we can close this and open the project structure. So next step, let's try to refactor things. As you can see, our lib.star file, it can only generate a test task, which is not what we actually want. We want to be able to customize it. So let's start by just making the name customizable. And since we have a really nice integration with IntelliJ, we can use IntelliJ refactorings. In this case, we can just extract parameter. So let's do this. IntelliJ detected two usages. Let's call it name. Boom. We just refactored our task generation. Not completely. We have test here. We want to have it as name. Here, this looks more like what we wanted. Now let's also customize version of the node that we are using. Right now we're using the latest tag, but it's not necessary that we want to always test against or like run scripts against the latest node. So let's use the same refactor and extract parameter and call it version. And IntelliJ does all the job for us. Wonderful. So now we customized name and version. What's next? Let's go back to the examples in the documentation, on the documentation website. And with Node.js, there are two common options. There are two common package managers that people can use. It's either npm or yarn. And we want to make our cirrus-module aware of differences. Basically, we want to be able to detect either this repository is using yarn or npm, and then based on that, either generate an npm specific task or we can generate a yarn specific task. As you can see, the difference is not big at all. It's basically just using different log file, using a little bit different command for installing and populating the cache, and then basically instead of npm run test, you do yarn run test. Okay, let's try to do it. As I mentioned, with Starlark, you can actually program things. So you can in a Cirrus Starlark specific dialect, we have a set of built-ins that you can import from the Cirrus module. The Cirrus module is the module that provides all the built-ins. And you can see there is a huge list of built-ins. And we are right now interested in the FS built-in, which is file system. Yes, you can access file system, virtual file system from your Cirrus task. If you're running your Cirrus module, you import it and have a Starlark configuration and run it locally via Cirrus CLI, it will be using the real file system that you have on your machine. Or if you're running it in cirrus-ci, it will use a virtual file system and will, under the hood, use GitHub APIs in order to get the contents and information about files. So let's import the file system. And now let's also extract this caching instruction into a method. We can again use IntelliJ refactoring extract method, and let's call it underscore node modules cache. Node modules cache. I named it with underscore to make it private. In Starlark, if your method starts or variable starts with underscore, it means it's private and you cannot export it, and therefore it's not available in the load statement. We don't want to have this node modules cache function just polluting the completion node module that we are writing right now. So let's make use of the file system. So we can do fs exists and check if yarn.log file is available. Yarn.log is available, and in this case we can simply basically just reuse the same cache instructions. So we have node modules as a name, node modules as a node modules as the folder that we want. Instead of cat package log JSON, we can do cat yarn.log. Okay, and here we will do yarn install. Wonderful. So now if yarn.log file, we will generate a proper node modules cache. We should do the same for the script. So let's do this. Let's extract that into underscore run script. Let's call it run script. Okay, let's extract it. Let's copy it. Let's copy the same logic. So if we have yarn.log, instead of npm run, we do yarn run. Okay, and now let's create a test for that. Let's just copy the npm test and call it yarn. Yes, please add. Okay, so we created a test, and now we can run internal test run, and it succeeds because there is no yarn.log. So now let's create a dummy yarn.log. Okay, let's associate it with the regular text. Okay, now if we'll run it, it started failing, and you can see that it expected yarn. So now let's do our trick with the update. Check the expected for yarn, and as we can see, now we have our magic in place. We now check if there is a yarn.log file, and we can generate tasks accordingly. Wonderful. Let's also commit it. Let's also commit it and call it support yarn. Cool. So how can we go even like deeper into this magic and what we can do next? Another common pattern in a Node.js repository is to have some bootstrap script. So you can let's start this time with the test-driven approach. So let's create a test case first, and then which we will be failing, and then we'll fix it. Isn't it fun? Okay, so let's call it bootstrap. And the idea behind this more advanced use case is that in a lot of projects, there is a package JSON that can define multiple scripts, right? So we have scripts here, and a common approach is to have a bootstrap script that you run after you have your Node modules installed. And this bootstrap script can essentially run some things like relay, for example. Relay, it's a compiler that will compile all your GraphQL queries into um, JavaScript that you can import. So let's make our Node.js module aware of this pattern, and if we can detect that package.json, which should be actually here, if package.json contains bootstrap script, we will automatically create a bootstrap script here. So bootstrap script, and it should run bootstrap. Okay, this is what we expect. Let's do test. You can see that we are failing. We are expecting to have the bootstrap. So now let's fix the test. Now let's go back to our lib.star, and here after Node modules, we want to have bootstrap optional script. Let's do optional script. Right. So let's create function bootstrap optional script. And what we will do here is now we need to use file system to read package JSON. Okay, so let's introduce it into a local variable called package.json content. Now we can by default return none. We can also do make sure that package JSON is there. So if not package JSON, then we return none. Then we need to parse the JSON file. As you might already guess, we have a built-in for that. Let's import JSON. Yes, you can run JSON. Another thing you can do in your Starlark script is to run and execute actual HTTP requests. It is usable in some of the use cases, and there will be a separate video about Cirrus hooks that you can subscribe basically to events when your tasks are failing or succeeding. And their HTTP built-in will be particularly useful to execute some GraphQL queries. Okay, let's do JSON. We imported the JSON module now. We need to load from content. Let's call it pj as package JSON. Now what we can do, we can basically do the following: if bootstrap in png scripts, right? Scripts or scripts. In scripts, we can do run script bootstrap. So what we have here is we are parsing package JSON if available, and then we're checking that the scripts field contains bootstrap, and if there is a bootstrap script, we will return instruction to run this bootstrap. So in theory, if we will go and run our tests, we should have it passing. So what we have here in bootstrap package JSON, we have bootstrap expected node script. Okay, what's the error? Scripts bootstrap. Oh, of course I forgot return. I was doing everything correct except not returning the right value. Okay, so here we have it. Let's commit it. So we have commit bootstrap, and yeah, basically here we are. We have implemented a cirrus module for a typical Node.js application. It has custom logic that checks if it's if the repository is using yarn or npm and generates scripts accordingly. We have even some custom logic that parses a JSON file, package JSON file, in order to verify that some things are there, and modifies the default script by providing this. You can see opportunities that it brings. We can write some auto detection. For example, if we see some linter configuration in repository, we can configure tasks that run this lint. If we can check if there is a configuration for release process and use release, and so on and so forth. So, and most importantly, this module can be shared externally, or for example, if you're a company or you have multiple very lookalike repositories, you can extract all the configurations in one repository, in one Cirrus module, and then simply load it in all of your other repositories, and you don't need to always copy paste things around. Okay, thank you for watching this video to till the end. If you still have questions, please don't hesitate to reach me on Twitter, or you can also write to Cirrus Labs support at cirruslabs.org. And yeah, thank you for watching.